Yo, what up everyone? This is LeetCode 206, reverse linked list. So we're given the head of a singly linked list. We have to reverse the list and then return the reverse list. It asks us if we can solve this problem iteratively or recursively. Now, when I first came across this problem, I solved it using a stack, but that's not a good approach because you're using extra memory when you don't have to. But I'll show you that approach, right? Um, it's not the best approach, right? Because you're using extra memory. So, um, yeah, but I can still show you it, right? Um, so we're gonna start off by creating the stack and then basically iterate through the list and pop the node, um, pop the nodes into the stack, right? And the basic idea here is like, right, this goes in first, this goes in second, this goes in third, this goes in fourth, this goes in fifth. And then when we're popping from the stack, right, this is going to be our first node, right? Then this is going to be our second node. Then we're popping again. This is going to be our third node. Then we pop this. It's going to be a fourth node, right? And that's how we're going to build out the reverse linked list. Again, this is not the best approach, but I thought I'd show you anyways. Just because it's kind of an easy solution to remember in case you ever, I don't know, come across this in an interview or something, and for some reason maybe you can't think of how to reverse a linked list. This is like super easy, right? You set your dummy node. Then you do something like this, right? Current.next equal to stack.pop, right? And then current is equal to current.next, right? And when there's nothing more in the stack, current.next is currently not pointing to null. So we need to do that, right? Because otherwise we're gonna have a cycle in the list, right? Because because the last node isn't gonna point to null. So we have to explicitly do that, and then we return dummy node.next, right? And you do something like this. It's not the worst approach. I mean, if you can't think of anything else, uh, you know, sorry, not node. I meant to say is not none. Yeah, it's not the worst approach if you can't think of another solution, but definitely not ideal. Right. Boop boop boop. Okay, so first of all, now let's solve this iteratively, right? So let's think about this. When we're traversing the list, how are we gonna basically reverse it as we go, right? And the way to do that is we're gonna have a pointer initially to null, right? Because technically this one that we're starting at, it's supposed to be the last node once we reverse it, right? So this one needs to point to null. Right now it's pointing to 2. So we're gonna have a one pointer that's gonna point here, right? And we need to use this, we need to point this 1 to this pointer, which is gonna be null, right? And then the second pointer is gonna be at 1. And what do we do with this? Well, we have to store, before we do anything, we have to store, or we have to track what is 1.next right now, right? This node.next. Right now it's 2. So we need to store this 2 somewhere. So we can reverse this, right? This 1 can point to null. And then we can shift the current node that we're on to 2, and the previous node now, the next iteration is not going to point to null, but it's going to point to 1, right? So I'll show you what I mean, okay? So this is the iterative approach, okay? So we're gonna, previous is gonna point to null first. The current node that we're on is gonna start at head, right? Okay, now we're going to say while, let me put this down a little bit. While current is not equal to none, right? Because we have to iterate through the entire linked list, right? So we're gonna keep going. When it hits null, that's when we know we can exit this while loop. Okay, so we're gonna say our next node, right, is gonna be current.next, right? So when we're starting here, next node is gonna be 2. I call it next node. You can call it temp or whatever. It doesn't really matter. It's the same concept. Now current.next, right? Current.next right now points to 2, right? Where should it point? Right? Current.next right now is equal to 2. it should be equal to previous, right? Because we don't want 1 to point here. We want it to point that way. Okay, so we're going to say current.next is equal to previous. Now we're going to have to shift previous, right, from here 1 to the right. So we're going to say previous is equal to current, right? Makes sense. Now current is currently at 1. What is going to be our new current node? What's going to be 2, right? And we stored it up here in this next node, which is essentially like our temp variable to keep track of. Before we messed with the pointers, right? We stored current.next, which is 2. We stored that in a variable. Now we're going to use that to shift the pointer over. Okay. Let's say current is equal to next node, right? Now when we're done, right, when we iterate through this list, our current is going to be here, right, which is going to be none. So we're going to exit this while loop, and our previous is going to be here, which is going to be our last node. But technically, after this is all reversed, previous is technically going to point to the head node, right? Because in this example, previous is going to be at 5. 5 is our head node. And of course, to return our linked list, we have to return the head node, right? I'm going to say return previous. And that should be it for the iterative approach. Okay? Now we can do this recursively. I mean, you can come across quite a few solutions on how to do this recursively, depending on how you write your function. Some of them can be a little bit confusing, so I'm just going to opt for kind of the more readable and easier to understand solution, right? So we're going to define a function called rec, which is going to stand for recursion. We're going to pass it the previous and the current node, okay? Now, if current is none, it means we exited the, it means we reached the end of the list, the linked list, right? So we have to return previous. Why? Because again, when we finish iterating through the list, previous is going to be the head node, right? So when there's nothing, when current is none, that means previous is going to be at the head node. So we just return previous, right? That's our base case. Else, right? This else, of course, is when there's still stuff, we're still iterating and kind of changing things up in the linked list to reverse it. Okay, so we're gonna say next node is gonna be what? Well, next node is gonna be current.next. Current.next is gonna be equal to previous, and then we're gonna return the recursive call, giving it current as a previous and next node as a next. Okay, and then down here we of course have to return none and head, right? Because that's what we're starting with. So again, pay attention to the parameters here. Previous is the first parameter, and then the current node is the second parameter, right? That's why down here we pass it none for the first parameter, because that's where previous should be, right? And then head is going to be the current node. It's very similar to our iterative approach, but instead of using a while loop, we're just recursively calling this function. So for example, right, we pass it none and then head. That's how we start, right? Our next node is going to be current.next. Well, current.next right now is head. So our next node is going to be 2, right? Again, that's like our temp variable. Okay. Now current.next right now points to 2. It should point to previous. So we're going to do current.next is equal to previous. Okay. So right now this current.next points to previous, and we have our next node that we have to look at stored in next node. So when we call the function, right, we need to pass this next node as our current node that we're going to be on, and this current node that we're actually on right now, before we do anything, before we call a recursive function, this current node that we're on, that's going to be our new previous, right? That's why when we return here, we pass it the current node as our previous, and the next node, right, as our new, current node. Okay, not too complicated. It can just maybe be a little bit complicated to wrap your head around the first time around. We've done a problem before where I said that the problem was just a knowledge check. I think it was the problem where you have to merge 2 sorted linked lists into one. This problem is very similar in that I don't think it's too complicated. You just have to make sure you have your knowledge of your linked list, so you know how to work with them, right? So if this problem was hard, right, maybe the recursive approach is a little bit hard, but if even the iterative approach was hard for you, then I recommend you brush up on your linked list fundamentals and try the problem again, and then it might make a little bit more sense, because if the iterative approach is hard, then it's very likely that you lack some fundamental knowledge on linked lists that is holding you back from doing this problem. So yeah, I hope this helped, and I'll see you in the next one.